In this video, we will dive deep into the impact of three technologies that shaped human history. Compass. The compass is one of the most important inventions in the history of navigation and geographical exploration. Instruments and measuring tools, from ancient tools like the cubit and sundials to modern laser-based devices, the history of measuring instruments reveals the ingenuity of humanity. Mechanical watches. The history of mechanical watches dates back to the 14th century and has evolved significantly over the centuries. This educational video offers a concise yet detailed exploration of the technological advancements that continue to shape our daily lives.
Hello everyone. I am very excited to share my new YouTube video with you, and I need your support to continue to bring quality and enriching content. If you enjoyed my content, please help me by like the video. It helps me reach more people and spread the message. Subscribe to the channel using the subscribe button below so you don't miss any new update or video. Press the bell to receive notifications every time I upload new content. And if you would like to support me directly and help me create more content, you are welcome to join me on Patreon. Your support is significant for me and allows me to continue investing in creating quality and enjoyable content for you. Thank you so much for joining and watching. I appreciate it from the bottom of my heart. See you in the next video.
The compass is one of the most important inventions in the history of navigation and geographical exploration, which played a key role in the development of navigation, trade, and geographical discoveries. The history of the compass began more than 2,000 years ago, and its invention is associated with ancient China.
Origin of the compass. Ancient China, 206 BC. The first mention of the compass dates back to the Han Dynasty, 206 BC to 20 AD. At this time, the Chinese discovered the properties of magnetite, a natural mineral with magnetic properties. The magnetic properties of magnetite were used in ancient times for fortune-telling and divination, but later it began to be used for navigation. These early compasses were pieces of magnetite, the so-called loving stone, suspended on a thread or floating in water, which showed the direction of the south. Development of Chinese compasses. By the 5th century CE, the Chinese had begun to improve the compass. They invented the so-called spoon compass, Sinan, which was a spoon-shaped magnetic needle mounted on a smooth surface. This needle could rotate freely and always pointed south. The compass became an important tool for navigation on land, and by the 11th century, it began to be used for seafaring. Chinese sailors used the compass to travel in the South China Sea and along the coast. Spread of the compass around the world. Arab world and the Indian Ocean. In the 9th and 10th centuries, Arab traders and sailors began to master Chinese compass technology. The compass began to be used for navigation along the coasts of the Indian Ocean and the Red Sea. This allowed the Arabs to successfully trade with India, Africa, and other regions. Arab scholars contributed to the development of navigation by using the compass for precise measurements and route calculations. Europe, 12th century, the compass came to Europe via the Arabs and the Mediterranean trade routes. The first mentions of the compass in Europe date back to the 12th century. European sailors quickly realized the importance of this device for sea travel. Early European compasses were magnetic needles attached to pins or floating in the water. The compass allowed ships to navigate on the open sea, even in the absence of visible landmarks such as stars or coastlines. Development of the compass in Europe, Middle Ages, and the Age of Discovery. With the onset of the Age of Discovery in the 15th and 16th centuries, the compass became an indispensable tool for European sailors. Thanks to the compass, famous explorers such as Christopher Columbus, Vasco da Gama, and Ferdinand Magellan were able to set out on long voyages and discover new lands. The compass improved the accuracy of navigation and reduced the risk of shipwrecks in unknown waters. During this period, the compass was improved. The arrow began to be fixed on a special scale indicating the directions, which made it possible to determine the course more accurately. Special marine compasses were also developed that used a wind card, a circle indicating 32 wind directions. Renaissance and further improvements. During the Renaissance, European scientists and sailors continued to improve the compass. In the 17th century, liquid-filled marine compasses were invented, which stabilized the arrow and prevented it from swinging when the ship was rocking. This significantly improved the accuracy of navigation, especially in rough seas. The compass in the scientific revolution, discovery of magnetic declination, In the 16th century, European explorers noticed that the compass needle did not always point precisely to true north. It veered slightly toward the Earth's magnetic pole, leading to the discovery of magnetic declination. This deviation varies depending on where you are on Earth and requires adjustments for navigation. Explorers like the English scientist William Gilbert began studying the nature of magnetism and the magnetic poles. His work in the late 16th century laid the foundation for the scientific understanding of magnetic fields and the compass. Development of cartography. The compass also had a huge impact on the development of cartography. Using a compass, sailors could more accurately determine their location and plot routes. This led to the creation of more accurate maps and charts, making sea voyages safer and more predictable. Modern compasses. In the 19th and 20th centuries, with the development of science and technology, the compass continued to improve. Gyrocompasses, which use the rotation of the Earth to determine direction, and highly accurate magnetic compasses were invented. Compasses became an indispensable element of navigation equipment on ships, airplanes, and other vehicles. Electronic and GPS devices. In the 21st century, traditional compasses gradually gave way to electronic navigation systems and GPS devices. However, compasses are still used as backup tools in case of electronic failure. Compasses remain important for tourist and military purposes, especially when orienting themselves on the ground and in conditions where there is no GPS signal. The compass played a key role in the development of navigation and geographical exploration, allowing people to travel long distances, discover new lands, and develop trade. Its history is the history of the discovery of magnetism and its use for the needs of mankind. Despite the development of new technologies, the compass remains an important tool for orientation and navigation in the modern world. History of creation and development of instruments and measuring tools. From ancient tools like the cubit and sundials to modern laser-based devices, the history of measuring instruments reveals the ingenuity of humanity. This video explores the evolution of measuring tools, from body-based units to precise scientific devices, showing how they shaped navigation, science, and engineering through the ages, transforming everyday life and technology alike. Pre-ancient times. In pre-ancient times, humans relied on basic tools made from natural materials like stones, bones, and wood for survival. Measuring tools evolved from observing nature and the human body itself. Early hunter-gatherers likely used simple forms of counting and relative measurement based on physical features like handspans, footsteps, or natural markers to track distances or quantities. Stone tools such as hand axes were the earliest instruments, helping humans measure and manipulate their environment. These basic forms of measurement laid the groundwork for the more refined tools that followed in ancient civilizations. Ancient times. Egyptians, 3000 BCE, developed the first known measuring tools for time and length. The cubits, measured by the length of a forearm, and water clocks for timekeeping were among their innovations. Babylonians created the sexagesimal system, base 60, used in modern time measurements like seconds and minutes. Classical antiquity. In classical antiquity, the development of instruments and measuring tools advanced significantly due to the growth of architecture, science, and navigation. Greeks, 5th century BCE, invented Greeks developed tools like the dioptra, an early surveying instrument, and the odometer, which measured distances traveled by counting wheel rotations. They also refined timekeeping with more sophisticated sundials and water clocks. Philosophers like Archimedes contributed to understanding measurement principles through inventions such as the Archimedean screw. Romans. Advanced engineering required accurate measurements of angles and distances, leading to tools like the groma for land surveying. Medieval and Renaissance periods. The medieval and Renaissance periods saw remarkable advancements in the creation of instruments and measuring tools. Islamic scholars, 9th century, made advancements in astronomical instruments such as the astrolabe and quadrant, a tool used for navigation and astronomy. The Renaissance sparked a renewed interest in science and precision. Galileo Galilei, 1600s, developed the thermometer and later the Galilean telescope, marking the beginning of modern scientific instruments. Leonardo da Vinci's engineering designs also advanced mechanical instruments. The compass and clockmaking also saw significant improvements, enabling precise navigation and time measurement. These tools were crucial for the era's scientific discoveries, explorations, and architectural innovations. The 17th and 18th centuries, known as the Scientific Revolution, witnessed dramatic advancements in measuring tools and instruments. This period marked the development of precision instruments crucial for scientific discoveries. Key inventions include the barometer by Evangelista Torricelli, which measured atmospheric pressure, and the micrometer, enabling precise measurements of small objects. The sextant, invented in 1731, revolutionized navigation by allowing mariners to measure the angle between the horizon and a celestial body. Innovations in clockmaking improved time measurement. Tools like thermometers and electrical measurement devices laid the groundwork for modern physics and engineering. These instruments propelled scientific inquiry, exploration, and technology to new heights. The 19th and 20th centuries saw tremendous progress in measuring tools due to advancements in industrialization, science, and technology. The Industrial Revolution sparked the development of precision instruments like the caliper and micrometer, essential for engineering and manufacturing. Electrical measurement tools such as the voltmeter and ammeter developed during the rise of electrical engineering. The invention of the spectrometer advanced chemical analysis, while the development of the X-ray machine revolutionized medical diagnostics. Development of optical instruments like the microscope further advanced scientific research. In the 20th century, digital tools, including GPS for navigation and digital calipers for precision measurement, redefined accuracy. These innovations fueled progress in fields like aviation, electronics, medicine, and manufacturing. In the modern era, the creation and development of instruments and measuring tools have been dominated by digital and automated advancements. Digital advancements have transformed measuring tools, with devices such as GPS, digital calipers, and laser-based distance measurers providing highly accurate measurements. GPS technology revolutionized navigation, providing highly accurate positioning data for everything from smartphones to space exploration. Nanotechnology brought the ability to measure at microscopic scales, crucial for fields like medicine and material science. Smart instruments with real-time data analysis, powered by AI and machine learning, are now widely used in engineering, manufacturing, and research, pushing the boundaries of what can be measured with unparalleled accuracy and efficiency. Each era brought improvements and refinements, leading to the sophisticated measuring instruments we use today across fields like science, engineering, navigation, and more. Origins of mechanical watches. The history of mechanical watches dates back to the 14th century and has evolved significantly over the centuries. Tower clocks have been a significant part of public life since the medieval period. These clocks were installed on towers in public spaces, often in churches, town halls, or castles, and served as a way to keep time for the community. In the 16th century, portable mechanical watches began to appear. These watches used mainsprings to store energy, allowing them to be much smaller and carried by individuals. The first of these watches were bulky and worn around the neck or as pendants, gradually shrinking in size and complexity. Mechanical watches trace their roots to the early 14th century in Europe, where they emerged from earlier timekeeping devices like sundials and water clocks. These early watches used gears and escapements powered by weights to measure time. They were large and typically found in church towers, serving as public clocks for communities. The development of portable watches. Peter Henlein's innovation, 1510, a German locksmith, is credited with inventing the first small, portable mechanical clock, known as a Nuremberg egg. This was a significant leap towards creating pocket watches. These watches used mainsprings to store energy, allowing them to be much smaller and carried by individuals. 16th to 17th century, pocket watches. Early watches were often worn on chains and attached to clothing. They were considered luxury items, mainly because of the precision craftsmanship required to make them. They still used mainsprings and escapements, the foundation of mechanical watchmaking. 17th century, the balance spring. The invention of the balance spring in 1657 by Christian Huygens was crucial to improving the accuracy of timekeeping. This innovation made portable mechanical watches far more precise than their predecessors. The golden age of watchmaking. The 18th and 19th centuries marked the golden age of mechanical watchmaking, particularly in Switzerland. Watchmaking innovation. The development of the lever escapement in the 18th century by Thomas Mudge became a cornerstone of modern watchmaking. This innovation allowed for smoother functioning and better precision in watches. Watchmakers like Abraham Louis Breguet revolutionized design and complexity with innovations such as the tourbillon, which further improved accuracy. This era also saw watches become fashion statements and symbols of status. Mass production, with the rise of industrialization, companies like Patek Philippe and Omega emerged, pioneering high-end watchmaking. The 19th century saw a push towards making watches more reliable and affordable. Many of the world's most iconic mechanical watch companies were founded in this era. The shift to wristwatches. In the early 20th century, wristwatches began to replace pocket watches as the dominant form of personal timekeeping. This shift was partly driven by World War I, where soldiers needed more practical and accessible ways to check the time during combat. By the 1920s, wristwatches became fashionable and widely worn by both men and women. Watchmaking houses like Rolex, Seiko, and Zenith became known for technical and design excellence. Modern developments in mechanical watches. Though quartz watches became dominant in the latter half of the 20th century, mechanical watches remained symbols of craftsmanship and luxury. Today, high-end watchmakers continue to produce mechanical watches with intricate movements and designs, often appealing to collectors and enthusiasts for their artistry and precision. Medieval era, 13th to 15th century. Early tower clocks were mechanical and often driven by weights. The need for precision in daily activities led towns to install large clocks on church towers or town halls. These clocks used striking mechanisms to chime bells, marking important. Renaissance and Baroque, 16th to 17th century. With the advent of better engineering, the accuracy of tower clocks improved. These clocks began to feature elaborate faces, ornamental hands, and architectural enhancements, serving as both functional tools and art pieces. Industrial Revolution, 18th to 19th century. The introduction of pendulum clocks greatly improved accuracy. More cities installed clock towers, which became landmarks. These were often mounted on public buildings, factories, or towers to symbolize punctuality and industrial discipline. Big Ben, London, UK. One of the most iconic clock towers in the world, Big Ben, officially known as the Elizabeth Tower, was completed in 1859. Its 13.5-ton bell rings every hour, and its clock face is recognized globally. The tower was constructed during the reign of Queen Victoria, and its precision has been maintained through regular upkeep. Prague Astronomical Clock, Prague, Czech Republic. Installed in 1410, this medieval clock is a marvel of both design and technology. Located on the Old Town Hall, it features an astronomical dial representing the positions of the sun and moon and a calendar dial. Every hour, a procession of the 12 apostles appears. Rathaus Glockenspiel, Munich, Germany. This clock is located on the new town hall in Munich and was installed in 1908. It features 32 life-sized figures reenacting historical events, such as a royal wedding and a knight's tournament. The clock chimes and the figures move at 11 a.m. every day. Spasskaya Tower, Moscow, Russia. This clock tower is part of the Moscow Kremlin and was constructed in 1491, though the clock was added in the 17th century. It is a symbol of Russia and plays the national anthem on special occasions. The tower stands at the eastern wall of the Kremlin and faces Red Square. Philadelphia City Hall Tower, Philadelphia, USA. The Philadelphia City Hall, completed in 1901, is a fine example of Second Empire architecture. The clock tower rises over 500 feet, and 4 clocks adorn its sides. It was the tallest habitable building in the world at the time of its completion.